Hey everyone, this is Lesson 4.1, Matrices and Data. The objectives for today, you're going to be able to use matrices to display mathematical and real-world data. You'll also be able to find sums, differences, and scalar products of matrices. The vocabulary for today is matrix, dimensions, entry, address, and scalar. All right, let's look at this example. The table shows the top score for girls in barrel racing at the 2004 National High School Rodeo Finals. The data can be presented in a table like you see, or a spreadsheet as rows and columns of numbers. You can also use a matrix to show table data. A matrix is a rectangular array of numbers enclosed in brackets. Here's an example of this information shown as a matrix. This matrix is labeled A, and it's made up of columns, rows, and columns. So here we have a row, and here we have a row. So we have two rows, and we also have our matrix is made up of columns. So here's a column, here's a column, and here's a column. So we have three columns. So this particular matrix has the dimensions 2 by 3. Now it's really important that you take note of your dimensions each time you are looking at a matrix, because it's going to save you a lot of time in the future, and you'll see what I'm talking about in just a minute. The address of an entry is its location in a matrix, expressed by using lowercase matrix letter with row and column number as subscripts. So you can see this particular matrix is labeled A, but when you're looking for the address of each entry, you're going to use a lowercase a with two numbers, and the first number will represent our rows, and our second will represent our column. All right, so in this case, it says look in row 2, which is right here, row 2, and column 1. So row 2, column 1, and we see that this 16.206 is right there at the intersection of row 2, column 1, and that is the address of 16.206 is A21. Here's an example of a problem you might see. It says the prices for different sandwiches are presented at the right. The first problem you'll have to do is display the data in matrix form. That's a really simple thing. We just put together a rectangular set here, and then we'll just fill in $3.95 and then $5.95. 560, etc., and fill your whole chart in. The next question says, what are the dimensions of P? And remember, the dimensions are going to be your row by your column. So we just want to look at our rows first, and we can see that there are 1, 2, 3 rows. So our dimension in rows is going to be 3. And then we look at our columns, and we can see that we have 1, 2 columns. So our dimensions for our columns is going to be by 2. So the dimensions of this matrix is 3 by 2. All right, here's an example. It says use matrix M to answer the questions below. The first question says, what are the dimensions of M? So think about that for a second. Hopefully you could see that the dimensions are going to be 3 by 4. We have three rows, 1, 2, 3, and we have 4 columns, 1, 2, 3, 4. All right, it says what's the entry at M32? So take a look at that and see if you can find the entry at M32. It's not really 32, it's 32. All right, so you should have noticed that M32 is going to be on the 3rd row and the 2nd column. So we can see that it's going to be 11. Hopefully you got that. It says the entry 0 appears at 2 addresses. What are the 2 addresses? So take a look at that. All right, we can see that the first 0 is here, and that is row 1, column 4. All right, so row 1, column 4, and the second 0 is going to be in row 2, column 3. Okay, so 1M, it's labeled M1 through 1-4 and M2, 3. Hopefully you could understand that. You can also add and subtract matrices. However, you can add or subtract two matrices only if they have the same dimensions. So let's look at two examples here. This matrices is a 2 by 2, and this matrices is also a 2 by 2. So we are going to be able to add those together. This matrices, it looks kind of interesting. We actually have we have 3 different rows, but 1 column. So this is a 3 by 1, and this is also a 3 by 1. So we can add those two together. But notice this has 1 row and 2 columns. So that's a 1 by 2, but look at this one over here. This has 2 rows and 1 column. So these two are not the same dimensions, even though they look close to the same. This is a 1 by 2 and this is a 2 by 1. So we cannot add those. And it's going to be the same thing here. We have 1 row and 2 columns. And this one, we have 1 row and 3 columns. So again, we cannot add those two matrices together. All right, so let's practice doing some adding. It says find the matrix sums and differences. So it says add and subtract, and be sure that you read it. It says if possible. So let's look at our W and our Y. So we're going to take the W and the Y, and we're going to just add each corresponding entry. So first of all, you want to write down your 2 matrix. Here they are, -3, -2, 1, 0, etc. And when we add matrix, when we're adding, we just take what's in the same exact address, okay? So this is row 1, column 1, and this is row 1, column 1, and we add that together. So that's going to be 3 plus 1, and that will go in our new matrix. And here is what it's going to look like. I'm just going to go ahead and do this. 3, 1 is added together. All right, and then we have our -2 and 4. Those are added together. We have 1 and -2. Those are added together. And we have 0 and 3 added together. And so when you actually add those together, the new matrix is going to be right here. And notice, whatever spot you got your numbers from, that's the same spot that they stay in. So 3 plus 1 is 4. Okay, our 2 and our 4 came from this first row, second column, and so the answer goes in the first row, second column. This next one that we had came from the second row, first column. So when you add those two together, it goes in the second row, first column. So it stays in the exact same place. All right. Here's another example. It says to add or subtract if possible, and this time it tells us to subtract x, take away z. So we're going to look at our dimensions first, and notice in x we have a column, have 2 rows and 3 columns. And in z we also have 2 rows and 3 columns. Since the dimensions are the same, we can go ahead and subtract, and we're going to be subtracting each corresponding entry. So you'll need to write down on your paper each matrix, and then all you have to do is subtract. So it stays in the corresponding entry. So 4 take away 2 is going to be 2. All right. 7 take away -2 is 9. All right. 2 take away 3 is -1. 5 take away 1 is 4, and so on. So you can see how to subtract. Pretty easy. All right, this next one says add x plus y. So the first thing we want to do is check our dimensions. X is 2 rows by 3 columns, and y is 2 rows by 2 columns. So here, our dimensions are not exactly the same, so we don't have to do anything. They can't be added, so you get to just skip that one. Here's a problem for you to try on your own if you'd like to turn the video off for just a minute and give it a try. All right, in this video, we're going to add B and D. So the first thing we want to look at is make sure our dimensions are the same. We have 2 rows and 3 columns. And here we have 2 rows and 3 columns, so we can indeed add them together. Remember, you're going to add each corresponding entry. So list your matrices down, and then we're going to just add them together. You could see 4 plus 0 is here. All right. -1 plus 1 here. -5, -3. All right. And these have all been, let's see, done for you. Let's see. So here they are. And your new answers are just in the right same place. Okay, let's keep on moving. Here's another one for you to try on your own. You can turn the video off for a second if you'd like to try that on your own. So let's look at this one. This one says take B and subtract A. So remember, we have to check our dimensions. This one, the dimensions are 2 rows and 3 columns for B, and A has 3 rows and 2 columns. And notice our dimensions, although they look closely the same, they actually are not. This is a 3 by 2 and then a 2 by 3. So on this problem, we don't have to do anything. It's not a matrix. It's not that a matrix can be added. So you don't have to do anything. One more for you to try out on your own. Take D and subtract B from it. Try that on your own if you'd like. All right, so the first thing we want to do is check our dimensions. So let's look at D. D is made up of 2 rows and 3 columns. And B is also made up of 2 rows and 3 columns. So we can do that. So we're going to write our matrix down. We're going to subtract the corresponding entries. And here you can see 0 take away 4 is -4, and they stay in the exact same place. Notice 10 take away 8 is 2. It stays in the same place. 0 take away 2 is -2. So there you have it. All right, you can also multiply a matrix by a number called a scalar. To find the product of a scalar and a matrix, or the scalar product, multiply each entry by the scalar. So look at this example. Use scalar product to find the price if 10% discount is applied in the price above. All right, so I'm going to show this to you 2 ways. I'm going to show you a little bit harder way and then an easier way. So the first thing you can see is we can rewrite this. You're going to multiply 0.1 and then subtract from the original number. So because we're going to find a discount, so we have to figure out what 10% discount is and then subtract it from the original. And I think this is a lot of work that the book shows you to do, so I'm going to tell you something that you can do instead in just a minute here. All right, so what you do is you take your chart and your table and change it into a matrix. So notice 7, 5, 7.5, 8, 8, and so on. So you change that into a matrix, and then what we're going to do is we are going to multiply that matrix by 1.1. All right, and so when we do that, here they've rewritten it out. I think there's a lot of rewriting on this exact example. So when we multiply 0.1 times our matrix, you end up with these values. All right, so what they're telling us to do is take our original table and subtract our new values, which were the 10% of our original. And when we do that, you end up with a new matrix, which is 6.75. Each t-shirt would be $6.75. That would be the 10% discount on that t-shirt, and the 10% discount on the sweatshirt would be $13.50. So I think that's kind of a lot of work to have to multiply by the 0.1 to find your 10% and then subtract it from the original number, and that's how you get it. I think that's a little bit more work. So what I'm telling that you could do, instead of subtract by 0.1, all you would have to do really is just multiply by 0.90. And if you put that in your calculator, 7.5 times 0.90, you're going to still get 6.75, and you don't have to do quite so much subtraction and different things. So notice that if you're going to get a 10% discount, that means you're going to pay 90% of the cost. And so 7.5 times 90% is going to give us our $6.75. So hopefully that will make a little bit less work for you. All right, so here they just rewrote the discount prices in the table. They took the information from the matrix and put it back into a table. All right, here's another one for you to try. Use scalar product to find the prices if 20% discount is applied to the ticket service price. So if you're getting a 20% discount, remember that you're going to only pay 80%. So all we have to do is take these numbers and we're going to multiply each of them by 80.80 or 80% instead of the subtracting, multiply by 20 and then subtracting. I think that's a little bit too much work. So you can multiply by 0.2 and subtract the original numbers, or do it my way and just put it in the calculator and multiply by 0.8. So here they've done it again for you. And your final answers are here. And we're not going to go through all of that, but you kind of understand the main idea of that, I hope. All right, and then you can rewrite it back into a table that's easy to read. Here's another example question that you might see. It says evaluate 3 times P and then subtract Q. So let's just check first. We always check our dimensions first. P is 3 rows and 2 columns, and Q is 2 rows and 3 columns. And notice the dimensions are not exactly the same. So lucky we don't have to do anything. There's no product, you can't do it, because once we multiply this, if we multiply by 3, it's still going to stay the same dimensions. All right. So, but now sadly we have to do one. This one says evaluate 3R minus P. So again, let's just go ahead and check. We have 3 rows and 2 columns, and P has 3 rows and 2 columns. So they're the exact dimensions, so we get to do that. So the first thing we're going to do is take R and multiply everything in R times 3. So 1 times 3 is 3, 1 times 4 is 12, negative 2 times 3 is negative 6, 3 times 3 is 9, 0, and 12. So that's what our new matrix is going to be. And then we subtract P from it all, and I'll show it to you nice and neat. And here it is. Ends up being 3, 12, negative 6, 9. You can see 0, 0, 12, 12. So here's our new matrix where we multiplied by 3, and then we subtract from P, which is 3, negative 2. This is our P. And when we subtract each of those, we say 3 take away 3 is going to be 0. 12 take away a negative 2 is actually 14, and so on. And so here's our new answer: 0, 14, 7, negative 7, 9, and so on. So you just have to follow, just kind of go slow and follow the steps. I don't think you'll have any problem with that. All right, here's an example for you to try on your own if you'd like. You could turn the video off and give it a try. This problem says to take B and multiply it by 3, take C and multiply it by 2, and then add them together. So the very first thing we always do is check and make sure our dimensions are the same. B has 2 rows and 3 columns, and C has 2 rows but only 2 columns. The dimensions don't match, and they won't match even when we multiply by 3, so we're not going to have to do anything on that one. Here's another one you can try on your own if you'd like. You can turn the video off for a minute and then give it a try. All right, this problem says to evaluate 2A minus 3C. So we're going to take matrix A and multiply it by 2, take matrix C and multiply it by 3, and then we're going to do some subtraction. So let's look at A to make sure it is possible. We have 2 rows and 2 columns. And in matrix C, we also have 2 rows and 2 columns, so indeed you can do that. And I'm just going to jump to the chase for you for those of you that did it. I think you can kind of see what to do here. And your final answer is going to be negative 1, negative 10, negative 6, and 47. All right, here's another one for you to try on your own. Again, I'm just going to get you started on it, and then if you want to do this one on your own, I'll show you the answer. All right, this one says to take D and then multiply it by 0.5 and then add those together. And we can see this is a unique one. There's one row and 3 columns, and we're just multiplying by itself, and which is going to keep it 1 by 3, so we definitely can do that. And so here is all the work that you would need to do. You can put it on pause if you want to look at each individual step. It's not that challenging. And that's where your final matrix is going to be. All right. So there are some properties. This is just for you to kind of keep in mind. The addition property of the commutative property of addition is true with matrices. Each matrix you can add and you can move them either direction. A plus B is the same as B plus A. The associative property is the same. Who it associates with, we learned these in chapter 1 or 2. And that's true for our matrix too. The additive identity is true. If we take one matrix and just add a matrix of all zeros, we're going to come up with the same matrix. And same with the additive inverse. If we take one matrix and add all of the opposites of it, the additive inverse, we're going to get a matrix of 0. And that is the end of our lesson 4.1, Matrix and Data. Hope you enjoyed this lesson. See you soon. Bye.